Welcome to our immersive video course specifically designed to equip you with the skills you need to create captivating 2D games using the Godot 4 engine. Whether you're a complete beginner or you have some programming knowledge, this course has been meticulously tailored to lay a solid foundation for your game development aspirations. From creating a Flappy Bird clone, where we learn about scene creation, input handling, collision detection, to replicating the addictive mechanics of Angry Birds with physics-based gameplay, your understanding of game development concepts will blossom. Experience UI-driven development, the charm of 80s platformers, puzzle games, and intergalactic adventures. Harness Godot 4's intuitive visual scripting system, which will empower you with fundamental programming concepts. In addition, delve into strategic gameplay using Godot's built-in AI with 2D navigation as you build a tension-filled game trying to avoid soldiers and escape from a maze. By the end of this course, you'll have a diverse portfolio of 2D games demonstrating your mastery of Godot 4 and also your ability to craft engaging gameplay experiences. So if you like what you see here, then feel free to enroll and hopefully we'll see ourselves on this journey together. I want to take a moment to talk about the versioning for Godot and the versions that we're going to be using during this course. One concern I know people have, it applies to me as well actually, is when doing courses is whether what they're going to learn is going to stay relevant. In this course, we're using the brand spanking new Godot 4, which is fantastic in my opinion. You can see on the Godot website here that the latest version is 4.0.3. This is at the time of filming this video. I'm sure that's about to change. When I actually started filming this course, it was 4.0.1, so it's already gone through 2 minor release changes since then. Now, none of those changes have actually changed anything on the course at all, but it could be possible in the future that there is some major change which fundamentally changes the way the games behave. If this happens, I'll update the particular section so that it stays relevant with that particular version of or iteration of Godot 4. If there's some kind of minor change, a slight menu change or something like this, probably what I'll do is put a note before the relevant video with a little bit of a screenshot of the change. But if you're worried or concerned about this, then don't be, because I'll make sure I keep everything up to date according to whatever Godot 4 is doing. This course is about Godot, so the first natural step is to actually get hold of and install Godot. At the same time, what you can also do is make the check that you can use the Vulkan renderer that Godot uses so that you're able to do the course. To get hold of Godot, it's very straightforward. You can go to godotengine.org, and when you go there, you'll find a button for Download Latest. The version at the time of filming is 4.0.3. This is changing quite rapidly, so when you watch this, you might have a different number to here, and I'll always be updating the course in case of any major changes, so don't worry if the number's different to what you see here at the moment. And just as I say that, this is an interjection from the future here. The course has been released quite a while now, and since it's been released, 4.1 has actually come out, so you're probably looking at the screen that looks like this. I've already gone ahead and checked all of the games that you're going to do throughout the course to see if anything is broken with 4.1. Everything seems to work pretty much identically as it did when I was using 4.0.3 during the course. And in fact, 4.1 is basically sort of a performance and bug fix update more than anything else. There was one slight change in the interface which helps with the coding, and I'll drop that into the coding videos later on when we actually start to look at the scripting inside Godot. But otherwise, you needn't worry if you're using 4.1 and I used 4.0.3. Everything is pretty much identical. If you click the download button, you'll be taken to the page for your operating system. I'm using a Windows computer here, so it's taken me to the Windows download. If you're using a Mac, then I know from doing it that you'll go to the Mac window, and also the same for Linux. You need to download the Godot engine and not the .NET version. That's really important. We're going to be using GD script, not C#, therefore we want the Godot engine. So click on this button, and what that should do is download you a zip file. When you've downloaded and extracted the zip file, what you should get is a folder, and in that folder you should have a couple of other files. Now in some cases you might just have one file. On my case here, or in my case here with Windows, I have 2. One of them is this console executable, and the other one is Godot itself. Please make sure that you extract the zip file into a folder and you don't run this from inside the zip folder itself. That's really, really important. So to start Godot then is as simple as double-clicking on the icon here. When it starts, it'll open up the project manager for you. If this is the first time that you've ever run Godot, you'll actually get this little window here saying, would you like to explore official example projects in the asset library? We're not going to do that, so I'm going to click cancel. Then you have this empty project manager here, and as you make projects, you'll find that this fills up with all the different projects. Now what I want to do is create just a simple intro project that we'll use for the rest of the section, and in this video we're going to test whether your computer is able to actually run projects with Godot. So what we can do then is click the new project here. That brings up a create new project dialog and some red text. Don't be alarmed by the red text here. All that's doing is telling us that the path that we want to put our project inside is not empty. To be able to create a project, we need to put it inside an empty folder because Godot is going to create a load of files inside there. There are a couple of ways to do this. One of the ways is to simply browse to an empty folder that you've already made on your computer. The other one is to actually just give the project a name and click Create Folder. When you click Create Folder, Godot will then create that folder for you inside this particular project path. So what I'm going to do is change this to Godot Intro, and then I'm going to click Create Folder. And now the text is gone because Godot has created this folder for me inside my document, and it's going to put all of the files inside there. For the render options, we're going to leave mobile selected here, and then for Git, I'm going to click None because we're not going to do anything with version control on this course. Now those options have been selected, we can click Create and Edit. That should then open a window that looks like this. Now we're going to do all the explanation of what we see on the screen here in the later videos. Nevertheless, I want to make a quick test that you can actually render things. So what we can do at the top then is, instead of being in 3D view, which is highlighted by this blue here, we can go to 2D view by clicking this. Then what we're going to do is just drag and drop this icon into the middle of the screen here. Make sure that it's in the middle of this outlined blue rectangle here with the pink at the top, the green on the left and the blue on the bottom and the blue on the right. Then what we can do is we can go to Scene and we can do Save Scene. We have a suggestion of a file called icon.tscn. I'm going to change that to test and do save. Now what I'd like to do on the top right hand side is make this test as to whether your computer can actually render the projects or not. So we can click the play button at the top here. That then throws up a window here. Don't worry about this for now. We'll just click Select Current. And hopefully what you get on the screen then is what I do, and that is then a window with the application actually up and running. If we look in the output, you can see that it's telling me it's using the Vulkan API and it's using my GeForce GTX 1660 here. If you get an error or anything wrong at this point, then probably your computer isn't able to render things using the Vulkan API. That only really applies to older computers, so hopefully that's not the case with you. If you do see a window on the screen, that's great news. That means you can follow along and do the rest of the course. So I'm going to click the stop button on the top right hand side here. And then what I'm going to do is see you in the next video where we'll start learning about how to use Godot. Hello and welcome back to our Godot 2D game development course. In this section we'll recreate one of the most addictive mobile games in history, and that's Flappy Bird. By building a clone of this popular game, we'll create a stronger understanding of some essential Godot concepts. By the end of this section you'll be familiar with physics, movement, collisions, the singleton and signal bus patterns, parallax scrolling, and of course the basics of user interface design. You'll witness firsthand how these principles come together and create a fully functional game. You're going to get your hands dirty by working on real game assets, experimenting with the physics engine, handling character movement, and creating our game's infamous sort of pipe obstacles. And you'll learn why and how to use the singleton pattern to manage global data, and the signal bus pattern to communicate between different game components. We'll bring these concepts to life in our Flappy Bird clone, illustrating their use in real-world game scenarios. What's more, we're going to make our game visually captivating by introducing parallax scrolling. This is a simple yet effective trick to create depth in 2D games. To polish off the game, we'll delve into the basics of UI design to make it more engaging and intuitive for the player. So let's dive into our first game and begin the journey. In this section, we're going to tackle the challenge of creating a simplified version of the iconic game Angry Birds. We're going to give it our own little twist and call it Angry Animals. This will allow us to have a fun exploration of the game physics and also multi-level design. What we're going to do is delve deeper into the realm of physics, and especially the rigid body 2D physics and collisions. We're going to introduce force, impulses and vector mathematics, and these are the building blocks for simulating real-world physics in games. As we catapult our bird characters into obstacles, you'll gain a deeper understanding of how forces and physics work in the game environment, and we'll also learn how to calculate and apply force impulses to launch the birds, and how to use vector maths to manipulate their trajectories. In addition, what we're also going to look at is the concept of inherited scenes. Inherited scenes allow us to create multiple levels easily and efficiently, and we'll be making good use of this feature to add variety and depth to our Angry Animals game. We'll also elevate the UI design skills a little in this section. Building on the basics learnt from the previous section, we'll add a little bit more complexity to enhance the player engagement and make the game more interactive. As we go through this section, it's important to remember to keep an open mind and don't be afraid of experimenting with the tools and techniques that we'll be learning to create your own variants of this game. Game development is really as much an art as it is really a science. So with that being said, we can start building the Angry Animals game. Welcome back to our Godot 2D game development course. This section is going to be a major leap in our course as we tackle some of the more complex aspects of game development. We're going to work with tile maps and physics. We're going to create one-way tiles, moving platforms, and also dangers. We're going to dive deeper into class inheritance and also introduce the concept of the Godot state machine. One-way tiles and moving platforms are going to bring dynamism to our levels, and the various dangers that we'll make are going to challenge the player, making the game more interesting. As said, we'll use class inheritance, which is a fundamental principle of object-oriented programming that's going to help us structure the game more effectively, and we're also going to learn about the state machine, which is a really powerful tool for maintaining state, and we're going to use that to create an end-of-level boss encounter. To enhance the gameplay, we'll introduce raycasting for enemy AI and incorporate shooting mechanics, both essential components for any engaging platformer. This is a really big section, I'll tell you in advance, and it's really packed with a load of new stuff to learn. It's going to be a challenge for you, but remember, every great game you've ever played was once a challenge also to the creator. So hopefully you're going to have fun with this. I know that I did when I was making it, and now we can dive into the code. Welcome back to this Godot 2D game development course. In this section, we're going to dive into the creation of a timeless puzzle game, and that's Sokoban. You might also have known this as Box World many years ago. This section is all about mastering tile maps, and there's a bit of a twist with this. We're going to build our tile maps entirely from code. The primary goal for this section is to understand how to dynamically create levels by reading details from a file. This practice is common in many games, and learning it will significantly boost your game development skills. We'll go through the process of constructing the game levels, the tile maps, and also the different elements of Sokoban completely through code. This is going to mean that we're going to need to dive even deeper into GD script, which also then enhances your knowledge and proficiency. What we're also going to do to make the game a little bit more competitive and engaging is introduce a feature to save scores to disk. This allows us to persist the scores then between plays. Sokoban is a game that I really personally love, and I think it's a testament to the fact that a simple concept can become a really engaging game, much like the Flappy game as well. So with that being said, let's start diving into the code and build ourselves Sokoban. Welcome back to this 2D game development course using Godot. This one is going to be a biggie. We're going to create a space shooter game. We're going to now start looking at some of the more advanced aspects of game development. We're going to look more at state machines. We're going to have multiple enemy types. We're going to have power-ups like shields and health. We're going to have different laser types, honing missiles, and all sorts of added things to make for some strategic gameplay. You'll learn how to use inheritance to create a variety of different enemies, and they're all going to have unique behaviors. They're going to implement different styles of shooting and avoiding and things like that. And what we're also going to learn about is the object factory pattern. This pattern helps us manage the complexity when we need to instantiate loads of objects, and inside the space shooter there are loads of things going on the screen at any one time. It's a really widely used design pattern, and we'll see it in action in our space shooter game. We're also going to tackle the challenge of creating infinite enemy waves. This is a staple feature of any good space shooter, and we're going to look at two approaches. One of them entirely in code, and the other one using Godot's custom resources, and this will broaden your game development toolkit. So with all of that said then, I think it's probably time that we start diving into the code and building up the space shooter. Welcome back to this 2D game development course using Godot. We're now on the final project, and this is going to be a sort of Metal Gear Solid type game where we're going to use stealth to try and avoid the enemy. In this section, we're going to focus on the built-in 2D navigation features of Godot. We're going to explore the usage of tile maps and then navigation regions, and further extend our tile map knowledge by incorporating multiple layers and also using auto tiling with terrains. Our game involves the player avoiding patrolling soldiers, collecting artifacts, and then running to the exit as fast as possible. You're going to learn how to program the AI of the soldiers to use the 2D navigation system to patrol and then chase the player when they've detected them. To make the game more challenging and realistic, we're going to introduce more complex vector maths than we've done before to actually calculate whether the player is in a soldier's field of view. This will add some realism, which makes the game quite a bit more engaging. Before we start, I do have to say the emphasis of this section is really going to be the core mechanics of the game. I want to get into the navigation with tile maps and also navigation regions, and we're going to spend less time on the UI and the scoring and things like that because we've covered that throughout every other single game through the section so far, so there's no real need to repeat it. So please bear that in mind, and that being said, we're going to jump into the code.